So we're out with the F-18 once again. We've gone over the plane in the past. So we've got the servo driven gear doors. Now we're back with a new set of springs. These are 1.2mm wire, 6mm diameter and 20mm long. That's from loop to loop. They fit perfectly in the suspension duty links. I also bought 1mm by 8 diameter, and they were way too soft. The plane sat under fractional compression but at rest, but just way too soft. These are too strong, but they'll work. I've had to order a different set, so next set is 1mm by 6, and that should work out very close to exactly right, but these will do in the meantime. The other thing we've got is a 3D printed missile rails which just flick off. Hopefully won't flick off in flight, so the lugs have been cut down to be just about 1.5 or 2mm. Got multiple double magnet rails in the wing and in the rail itself. Can't even get the key lined up. There we go. So we'll find out. One problem could be bumps across the ground. Will they, cause vibrations and the missile rail to fall off just because it's going across rough ground, and this ground is getting fairly dry. It's not bad surface, but it is bumpy, so we're about to find out. Plus the main gear suspension is too stiff. It's not going to absorb anywhere near as much as it really needs to. So until I get the new springs, they're going to be much bumpier, and therefore more chance the missile rails will come off. So until I get the softer springs, it doesn't really prove if the missile rails are strong enough or not strong enough. If they stay on, they're definitely strong enough. If they come off, it doesn't mean that they're really too weak. So anyway, we'll send it up flying. We'll find out what happens with them. So we're ready for flight 1 of the F-18. We're running the full complexity mode, which is what I use all the time now, which means full span flaps, and ailerons only come up halfway, blah blah.
Flaps stage 1. Flaps retracted.
We've got a person with his dog going up and down the field. We're going to have to point not into the wind. We'll take off with low level flaps. No one's out that way. Hopefully the plane operates fine. And
33.5 volts.
So we're about to find out.
0.1 amps.
We're ready for takeoff.
7 milliamp hours.
Training across the ground fine. None of the missiles have come off yet.
114 amps. 139 milliamp hours. Flaps retracted.
Oh, it's getting blown around a little bit.
31.1 volts. 51 amps.
Dropping out of those turns a lot.
537 milliamp hours. 29.5 volts. 108 amps. 813.
Flying alright. Both missile rails are still on. They didn't try and fall off on the takeoff, so that's a good thing.
0.9 volts. 33.9 amps. 1.
Oh, it's getting blown. Like the MiG-17 was getting blown around. This gets blown probably because of the short wingspan. It just gets sudden flicks, like 45 degrees, 30 to 45 degrees of flick just by a gust of wind. Yeah, while the wings are dead level and you're concentrating keeping them there, it's alright, but as soon as a bit of wind gets under it, it rolls as easy as anything. Noting that those missile rails weigh some amount mass, more than the stock ones, which gives it inertia to resist roll. So even with those, it's rolling easily.
31.6 amps.
Fish just wobbling around.
South end, 427 milliamp hours. 30.2 volts. 31.2 amps. 1. South end, 568 milliamp hours.
Climbs quite well under its 8S power.
0.4 volts. 103 amps. 1. South end, 851 milliamp hours. 29.5 volts. 43.6 amps. 2. South end.
So because there's a little bit of wind, I'm just flying faster than I normally would, and it's still struggling with gusts and etc.
43.8 amps.
So the next thing, we have to get the afterburners into it. That'll make a nice little addition. Might do that during the week, should get some time.
0.3 volts. 43.6 amps. 2. South end, 443 milliamp hours. 29.3 volts. 27.
Holy crap, that flung over on the second half.
South end,
I couldn't even reduce it in time. There's definitely a crosswind and rotors coming off those trees, so that's not a good idea to do anything low at the tree height or lower.
2. South end, 800.
Yeah, I mean the MiG wavered around, but because of this stubby wings, this is really getting affected. So and it's not windy, it's just like mildly windy. Cool. See, again, I just started the bank smoothly and it flung over.
29.1 volts. 39.1 amps. 3. South end, 100.
Oh, that's time to land.
Milliamp
We
hours.
have to land from left to right, so it's gear out, doors will be opening, gear will be coming out, low level flaps.
0.3 amps. 3. South end, 353.
So we turn
milliamp
back,
hours. Flap stage 1.
full flaps.
Flaps set for landing. 29.4 volts. 18.1.
Oh, that is getting affected by the wind so much.
454
Now, considering the
milliamp
landing
hours.
gear is extremely stiff,
29.8
it still came in very nicely.
0.1
I think on this plane,
188
it's still too stiff.
milliamp hours.
I'll just check the
Throttle cut set.
battery numbers.
Flap stage 1. Flaps
So
retracted.
we're above 3.7, nearly 3,500 milliamp hours out of 4,500.
Meters. 93
Now,
dB.
this ground is not overly smooth, but one benefit you'll get, this gear is badly designed, and the main gear, if they move at all, they steer because they swing inwards. They don't actually travel in line with the travel direction. So if one of them, if both equally compress, you'll end up with toe out, equal toe out, so that's fine. But if one compresses more, you hit a bump and one side compresses more, the plane will steer dramatically to that side, and no, it steers to, I'm trying to think, when it compresses, say the left one compresses, that will steer it rightwards, which puts more weight on the right, which makes it compress more, makes it steer worse. So you basically, your wing tip is going into the ground. It's not just because F-18s have narrow track, it's because this is really bad geometry on the landing gear. So one thing with these overly stiff springs means very little compression. Even if it compresses, they're coming straight back out, so they're tracking true 95% of the time. As per that landing, it still ran through the ground. was a little bit skittish, but there's crosswind and wind making it hard to track straight anyway, so, and it's trying to get under the wings and, you know, like under one wing. So all in all, that was a very good landing and tracking the ground considering the conditions, and that shows this overly stiff landing gear, because of the bad geometry, is actually well suited to it. It had no need to have suspension damper. You really need that in the nose to stop, because if the nose pops up on a plane, you're going to get a higher angle of attack and it's going to try and fly again, quite often lifting the nose even stronger, then stalling and diving the nose in. So the nose gear is very important to be correct. The main gear is nice to be correct, but not on this plane because of that bad geometry. It virtually says you do not want suspension, you want it minimal, you know, nice and stiff. It may very well be these overly stiff springs are actually, you know, perfect for the best end result. I'll still put on the weaker ones when I get them just to check, because I think can't hurt to be a bit softer, but we'll find out when I use them. Meanwhile, the missile rails totally fine, didn't try to come off at all. If it ever did dip into the ground, you know, they're coming off. They come off easy under, you know, decent force, but not under normal operation force. So that magnet strength is proven to be perfect. It was a bit of a calculation of testing, and yeah, that should be right, but you don't know until you actually fly the plane, run it over bumpy ground, see what happens. End result, perfect. So that's flight 1 of the F-18.